So this is problem 3.3 out of Griffiths Quantum Mechanics. Before I begin this problem, I just want to ask if you wouldn't mind liking this video and subscribing. It's a free way to support me, and I post a lot of content that goes through undergraduate physics textbooks. So if you're somebody interested in that, I think you have a lot to benefit from my channel. Okay, now let's get into the problem. We want to show that if h q hat h equals q hat h h for all h in the Hilbert space, then that holds true for any function f of g. So that's what we want to show, and it gives us this hint where first we let h equal f plus g and then f plus ig. So we want to show these inner product relationships. And we're going to basically follow along with the hints that the book gives. I think that's the best way to do it. So this is our assumption. This is where we start with. This inner product, that's not what I wanted at all. It's a running kind of joke at this point that, no, I don't even want text mode. I wish I could make it never pop up ever again, because I just never use it. Okay, I think we're okay now. Technically, these are operators. Probably not going to keep doing that as we go on, though. So our first hint says let h equal f plus g. So let's do that. Let's just plug it right into what we have above. We have this bra f plus g, and then q acting on f plus g. And what we want to do here, so this is the left hand side. This is, you could think of as being f plus g bra, and then for the ket, qf plus qg. So all we've done is we've distributed this operator, which is completely fine. Which then, let's see, we can expand this accordingly. So we have this inner product. So the first part here, plus, and then let's see, we're going to have the exact same thing, but on Q, or I'm sorry, on G. And then we're going to have our G inner products. So all I've done is broken this up into multiple inner products. Nothing too crazy. So this is, you could think of as being, this might be helpful, at least for me. That is your left hand side. Let's keep it that color. But there's also, and by left hand side, I'm referring to to this part. But there's a right hand side as well, so we want to talk a little bit about that. Okay, so on the right hand side we have Q acting on f plus g, that's in the bra, and we have our ket here. And it more or less works out to something very similar. Just distributing that Q operator like such. And we're going to get the following. So this is just writing this out into multiple inner products. And this is the exact same thing we did above, where we're just essentially expanding it. I think this mostly makes sense, right? We're just essentially distributing these into a sum of the inner products instead of the one big one. Okay, so that's the right-hand side. And we know that the right-hand side and the left-hand side need to be equal to each other. And on the right-hand side, I just want to rewrite two parts. So this I can write as this, since it's a Hermitian operator. And we can do the exact same thing here. So we're just taking advantage of the fact that that our Q is Hermitian by our assumption. So then, hopefully you can see that since the last purple line and the last blue line need to be equal, we can see that these will drop out and that these will drop out. Okay, oops. So then, what we're left with is the following. So our, I guess you could think of them as cross terms for both the left side and the right side. And I'm going to just call this equation 1. We're going to stop there, and now we're going to use the second hint, which is very similar, but it's F plus IG now. We're going to follow the exact same procedure that we did above, and thankfully these values were picked out in such a way that when we add our two resulting equations, we should get the result that we want. Plus IG, F plus IG. So I've just plugged it in at this point, and on the left hand side you'll get something very similar, except now we have an I. Now the only thing you want to keep in mind here is when we're doing the bra F ket G1, your I will be positive because your I is in the ket there, which is important because in the other case where our I, so like when we distribute this over, that's in the bra, so we have to remember to take the complex conjugate of that. So that'll actually be minus I by what bra and kets do. And then this is the last part. Nothing too crazy there. Just remember your y squared is -1. So that's just a scalar. That's your left-hand side. Your right-hand side, very similar. And that these should be equal. We'll have Q FF plus I. Now our Q will be just in our bra, basically. That's essentially the only difference here. And once again, that's a bad Q, but hopefully you see that these are equal, since I can just as easily move the Q to the bra. And these two are equal for the same reason. I can move that Q over. It's the same thing we did before. So, oops. And one other thing we can do, since we only have these I terms, we can divide out an I. So I'm just dividing by I on both sides. And what are we left with? We'll be left with the following here. Equal to QFG minus QGF. Okay? We'll call this equation 2. And if you notice, equation 1 and equation 2 are very similar. Once again, we could move this Q over here to match with where the Q is there. And then the other term right here, we could move this Q over here to match with this term, or the other way around, it doesn't matter. The important thing to note there is we're going to get these cancellations of the cross terms if we do 1 plus 2. So we get just this. Again, that other part is going to be just 0. Technically, there's going to be a 2, but it's not going to matter because there's going to be a 2 on this side as well. So obviously, we can just divide out the 2 from both sides, because you'll have this in yeah, those giving you 2, but then you'll have the same thing over here. And again, we can move those Q's around if we want. But the important thing is those 2's end up dividing out, and you get this relationship, which is exactly the relationship that we wanted to prove. Hopefully that makes sense. I tried not to skip too many steps, so hopefully I didn't do that and I didn't go too fast. So if that helped at all, I would appreciate it if you would leave a like and subscribe, and I'll post more solutions going forward.